Hello everyone, my name is Raghu. It's a tough act to follow after Angelina. If I was 20 years younger, if I was sitting in the audience, then I'd be just walking out and starting my own startup, maybe first. 20 years later, I did do it, but unfortunately, I didn't attend a session like Angelina's earlier. That is my only regret. Let me briefly introduce myself and then we'll also go to some of the slides here. Worked with technology for many years. So computer engineer, did a MBA in people leadership, and started selling smartphones before the iPhone was actually sold in Singapore. So was ahead of the curve, at least let's say, with the smartphones. Then went on to AI startup. So started my own artificial intelligence startup on predictive shopping in 2014 when AI was not a buzzword. I wish I would have started it 5 years later and wish there were more accelerators at that time for AI, but unfortunately there wasn't. I did start a startup, grew the startup, and then went to cloud technologies, and then was selling quantum computers for the last 5 years. So I've sold physical quantum systems across Europe, in Singapore, couple of processors that you see in the quantum systems. Actually, with the NTU, is sold by me through my previous employer, IQM. And that's when I realized that, okay, this is when I need to start a quantum company. I should not miss the boat. I've seen the smartphones and then the AI, I said the cloud. This is my opportunity to make it a home run. And that's how we started a company called RAQS Quantum. It's also co-founded by two other professors, one professor from NTU, Professor Rainer Dunke, and also Professor Dario Poletti from SUTD. So that's a brief context of the journey itself. So I have worked in different companies, but I've been on this side of the table. So I've been as a student following the technology, but also on the business side. Then I've built many businesses globally and now in the quantum field for around 6 years. And I'll bring a different perspective. I'll bring the perspective about commercialization of quantum technologies. So not on the tech itself, not on the business, but also on the careers around quantum and the way I see it. Yeah. Also, why is it global? So my, again, claim for building a global business is I've sold in Middle East, multiple businesses. I've lived in Europe for 15 years. And also then in Singapore for the last 3 years, come from India. I've grown a business in Asia Pacific, in Hong Kong. So there are multiple places that I've lived. I also build businesses. So maybe that's the claim why it's also a global business, and quantum anyways is global these days. All right, so the economic value, right? So if you speak to any one of them, be it any consultant, be it the BCGs to McKinsey's and so on, there are different numbers that you keep throwing up. One would be, if you look at BCG, quantum is said to be a potential of about 800, 850 billion. If you look at McKinsey reports, now the numbers have been a bit tapered, but it's been around 2 trillion. So it doesn't matter whether you are in this extreme where you think that it is 850 billion or whether it is 2 trillion with quantum, the market opportunity is definitely there. And there is a lot of hype around the technology. And there is also a lot of momentum around the technology. So I do see that there is opportunity around that. And that is where we see from 850 billion to 2 trillion, there is a big opportunity here. And any number, even if it is 50% of it, it is a big opportunity. And that's why careers can be built and that's why businesses can be built around it. And it is global in nature. So if you pick any country, any large player right now with the national programs, there are dedicated national programs around quantum. And this is again an opportunity to build careers, build research careers, or even opportunities to collaborate across boundaries. And some of the notable players are US, China, definitely investing a lot. Japan, they've been, even last week, since this slide has been developed, Japan has committed more money into quantum. Taiwan is investing a lot into quantum. Singapore itself has been also committing a lot of money into quantum. So there's enough public money coming in. And why is it relevant? It is similar to the space programs. Before SpaceX became big, there were NASA and others who were investing public money into the space programs. And then now you see a lot of space companies coming up or space tech companies coming up. Similarly, this is a disruptive technology where public funding is needed for early adoption, and we clearly see that it's happening across the world. Back home, very close, if you look at different markets, Singapore, Japan, Korea, India, there are a lot of quantum initiatives coming up and national funding coming up, including Malaysia. Malaysia, just today I saw some paper that was published around Malaysia's quantum strategy. And there is a ASEAN Quantum Summit next week. Some of you are also participating there in Johor Bahru. So even Malaysia is entering into the quantum race and investing a lot into it. If you look at one of the key topics, at least in this slide, which I would want you to focus on, and why it is an opportunity for many of you, is that Japan, for example, always a leader in adopting technology and also in innovation, targets 10 million quantum computing users by 2030. So in another 5 years, we are going to see 10 million quantum computing users, one from one country, Japan. And this is quite interesting. This shows that there is not just the hype around the technology, the scientific breakthroughs, quantum algorithms, and everything else that we are going to discuss about, but there are going to be end users. And what happens when there are end users? The market explodes. What happened with the chat GPT movement? Moment it was put to consumers, it was given to the hands of customers, the market exploded. Same thing we saw with the internet boom. Same thing we saw with cloud. Same thing we saw with smartphones. And we are seeing similar journey coming. What we cannot predict is how soon will it be. Will it be in the next 5 years, as Japan has put it, or will it be 10 years? If you speak to some of the professors in the room, they could be slightly cautious, slightly pessimistic. But if you talk to the accelerators and the business guys in the room, we might be slightly more aggressive and more optimistic. But whichever spectrum, the end of the spectrum you are in, the opportunity is definitely for real. And Singapore is again a fantastic quantum ecosystem. It is growing, it is thriving every day. There are new startups coming up, there are new companies entering into Singapore, there are new accelerators setting up, and there are more partnerships being done by National Quantum Office from Singapore. So this is something where we see that there is a vibrant ecosystem, and as we have historically seen, Singapore adopts technology faster than any other market. Once a technology is there, Singapore is one of the best markets to adopt those technologies, and we see that also in quantum. But there is already a thriving quantum ecosystem right now in Singapore. And this is also put in relative scheme of things. Gen AI, again, the numbers can vary, but it's just to give you a comparative figure. Gen AI will have about 4 trillion, let's say, on the higher end in terms of economic value. And quantum almost is a half of it. So that again shows the big scale that is available. And the kind of industries we see, again, many of you have engineering or tech background, but you might also be interested in different industries where you might want to enter in and build a career. And or if some of you would want to pursue research in certain specific areas, take for example material research or chemical research. So quantum is going to play a big role, and this slide highlights it. If you look at the early adopters and then where the market is going to become big, some of the markets we see at this point already as a company are financial services, already adopting quantum today. Chemical industry already investing a lot of money into quantum today. And also we see pharmaceuticals, healthcare. So these are the three already seeing happening today. And what we see in the future growing big is again financial, sustainable, chemical, travel, optimization problems, all being solved using quantum. It's not only quantum, so it's not to again put something that quantum is going to replace classical. No, that's not the case. But these two technologies are going to coexist, and we already see a lot of things happening around it. And that also takes me to the next slide, which is very important to understand that we saw the Singapore ecosystem. We saw that there are industries that are going to adopt, but quantum is already quite crowded. There are different ways to build quantum computers. There are different quantum algorithms companies. There are different quantum applications companies, cloud providers, the quantum cloud providers. That all of this is already here. And what is needed for an industry to be built? You need to have all of these players along with the public funding to show that there is traction. So all the signs that a business or a commercial person looks for, or what a McKinsey would look for in their strategy report, is there public funding? Is there research breakthrough? Are there companies that are coming up? Are there investors putting in money into this technology to back it up? Are there startups that are coming up? All of them are yes. Then where is the uncertainty right now? Which technology will be a leader? And then the counter argument for that is, why do we need only one leader? We buy different smartphones, right? Some of you have an iPhone, some of you have a Samsung, some of you have something else. Similarly, I see some of you having MacBooks, others have Windows laptops, and many use Linux. Similarly, there will be different technologies and different modalities, even in quantum, that will exist together. And that we see in quantum for sure. Which one will be the first one, which will have the big breakthrough? I think the verdict is still few years away, but there are clear winners that are coming up in this race. And we see some of them also in this room, some of our friends who have done fantastic work on this, on scaling up quantum systems. So what do I have as a message for you? Yes, we talk about quantum. Yes, we talk about quantum software, but there are many areas where you can play a part. Because to build quantum computers is an opportunity, right? Opportunity on the hardware side, not just on the processor. It could be also on the control electronics. Cables, the wiring is a big component at this point in time with superconducting. So if you are studying electrical, if you are working on electronics, there are different opportunities there for you to actually dig deeper, because this is an ecosystem where you will have a big opportunity to build a career on. If you are on the software side, how does a quantum computer connect with a classical computer? That is a basic thing. Like, how does it work? How are the workflows handled? How do you send the code? How do you break down a code? What is a hybrid algorithm? There's again a unique opportunity that is coming up. So in a standard business side, it's called the value ecosystem, right? The value chain, and where is the ecosystem? You can see it every level, big opportunity that is coming up for as to build a career. If you are just a programmer who wants to build end use cases for a specific industry, that will always be there. That is again the gold mine where there will be a lot of opportunities on quantum algorithms and quantum applications. So pick a piece of this entire ecosystem where you would like to specialize in, and then just go deeper, because there is opportunity. That's what I can send as a message, saying you don't need to build quantum hardware. You can play your role depending on your strength areas, depending on what you're specializing in or what you want to continue researching on. There are different areas where you can play a part. And then we see also value shift. So today's value, if you look at this slide, is very interesting, is it's more on the hardware side, because we are trying to make hardware available, be it on-prem or through it cloud. There are a lot of investments that are going on. But hardware, as we have seen, again, having been in the hardware sales business for 20 years, it just gets the value or the profit margins go down. And then the more value keeps coming up on the application side. On services side, you see a lot more value growing, and quantum is no different. So this is again put up by McKinsey, where the value today to capture is on the hardware, because there is not enough quantum systems available. But we see that over the next 5 years, the value will slowly go towards the services side. And that's where the opportunity is for building a future career. And some people say, what is a chat GPT movement? Or this question keeps getting asked, even if I'm in the boardrooms and leadership teams. It's called the Q Day. So Q Day is coming up. Now we don't know when it would be. It could be equivalent to the Y2K movement or chat GPT movement. But there is a day where powerful quantum systems will be there. It can break the internet security. It can break a lot of things. And that is why the industries are trying to put in money today. So it is not just on the compute side. You can also look at things like quantum security, quantum communication. So it opens up a totally different career opportunity for you if you're going to specialize in one of these areas, because Q Day is definitely coming up. So what do we do at RAQS? Again, how do we approach this? We focus on enterprise applications. So I've been selling quantum hardware. That is why the previous slide. So I know that ecosystem really well, but we saw one gap in the market. We saw that enterprises were asking the question, Raghu, all of this is good. Yes, $1 trillion, $1 billion. The moment you put this billion number, everyone is interested in a boardroom. But then they say, how do I get started? And the moment you say, oh, you need to have a quantum center of excellence, you need to hire quantum researchers. Quantum is based more on physics, and computer engineering is more on mathematics, logic, 0 and 1, qubits. The moment you put all these terms, they would say, very interesting, come back after 2 years. So they kick us out. So we saw that that was the gap that most of the enterprises were struggling with. How do we get started? Is there value in short term? Can I really train my people? Can I upskill my people right now to actually develop into quantum engineers in the future? So that was a question that enterprises kept asking us. And we saw this opportunity. That's why with Professor Dario and Professor Reiner, then we said, let's start something around this. So we build real world applications with quantum solutions. Yeah. So we focus on 4 different things. Again, like many companies that would be there, if you pick any of the consulting firms, they start with the proof of concepts and the enterprise applications. So the number 1 becomes also our bread and butter, where we work on quantum applications. But we notice, as I said, the challenge is enterprises are not ready to buy quantum applications today. So we saw the opportunity in the second one is upskilling the workforce. So education became a big thing. So in Singapore, we are also Skills Future credited. So Singaporeans and PRs can get government funding to be trained by us. And we run a program with Singapore University of Technology and Design where we can certify professionals on quantum AI training. So we do this in person. This quarter, we have trained about 75 people, including in Dubai, also in Singapore. So we have conducted these sessions with SUTD. So this is where we see an opportunity on upskilling the workforce. The third one we help is also on the national strategies. Right now we are discussing with a couple of countries in Southeast Asia to build on their national strategy and how should this get started on quantum. And the fourth one, we also help quantum companies with business development because we do know the Asia Pacific market well. We have been participating in several tenders. I personally have participated in the Taiwanese tender, Singapore, as well as in India. So we participate in these tenders with quantum companies with business development. So these are 4 areas where we contribute in, and these are our 4 verticals within the company. Why do I say this? Now I'll go into deeper, not on the company, but why do we look at number 1, the enterprise question? Because enterprises have these challenges. They keep asking us, we don't know where to get started with quantum, or we can't find an appropriate use case. Mainly, the challenges are in these industries. Nobody is focusing on it, or not many people are focusing on it. Public sector, energy sector, and if you look at automation, aerospace, and also R&D. So we see that there's an opportunity in these areas, and at RAQS, we focus on these particular industries. And we also use 2 different approaches here. If you speak to a quantum physicist, there's an argument around whether quantum inspired is real quantum or not. But let's leave that debate aside. So we do take 2 different approaches. In a short term, we can deliver results using quantum inspired approach, where we use tensor networks and other approaches to build a short term solution. It will have quantum properties using classical system. So when we start working with customers, we start to deliver results within say 6 months time. We show some incremental results for them that they are happy and they can present it to the bosses saying, hey, if we use quantum inspired, these are the results that we are already able to deliver. This is how we build the proof of concept with customers. But our end goal is definitely to work on quantum algorithms. So we build quantum applications with enterprises. So this is a medium term, say 2 to 3 years time frame. You start using quantum algorithms and we deliver the solutions for it. So we use both quantum inspired and quantum algorithms depending on the customer. Some customers are R&D heavy, so they are willing to invest into research and development. So we directly work with quantum algorithms approach. Some customers are short term saying, Raghu, I need to see a result in 6 months time. Then we also recommend them quantum inspired approach. And this is again, the benefits are short term. You can see results in quantum inspired, it's measurable, and it builds on the classical framework that they already have. So it's very easy to adopt it for us and show incremental results. While with the quantum algorithms, it's longer term using full quantum power, but it's dependent on quantum hardware being available. We innovate. Now I won't go into detail, but these slides can be available for you just to see. So we define and plan the first phase, which is where is the problem. Most of the customers don't even know which use case can they use in. So this is where we go, we step in and we say, not all problems can be solved by quantum computing. There are some problems where you don't need a quantum, you just need a classical. So we first ensure that we understand which problems are they going to solve. That is identifying the use case. Then we look at it in terms of preparation, whether they need the quantum inspired approach or quantum algorithms approach. And we start working on the proof of concept and the longer term projects. We also help them build quantum center of excellence. So where if you do not have a quantum employee in the company, nobody understands it. We, as I said, upskill, but we also help you set up a quantum center of excellence so that a couple of your colleagues in the company can be quantum, let's say, trained, and then they can start leading this quantum center of excellence. We help them set up the quantum center of excellence, and then we help them work on quantum projects. And then we also build value through the ecosystem. So we do work with governments, we do work with also investors, accelerators. So at RAQS, we have good connections, again, having been in the industry for a long time, before the industry became really big. So we have had this opportunity to work with universities. Definitely in Asia Pacific, you pick any university, we would know them. We are already collaborating with them. With corporate users, we also know a lot of them. So we start working with them, we start engaging, and we build this quantum ecosystem together using our network. And we are also the founding member of QBN Asia Pacific, where Kai Ventures is also one of the members in Europe, and we are trying to pull them onto the APAC also membership. But yeah, so this is again a network which we are one of the founders in Asia Pacific. All the quantum companies are already members. So you guys should also check out if you're interested. There are a lot of working groups where you can contribute to and where you can also learn from. So there are different working groups depending on which stack of value chain you are in. Either you are on the software side, services side. So these are available. So please look into this. So in the closing, what I would like to say is, see, it is becoming a reality, right? How much ever I say the question would come up, is there real careers to be built? What should I study? So those are questions that we can definitely answer. But few things that we do see is it is becoming from lab to fab to companies. We see that it is happening. This is clear. So you need to get started. I'm impressed that this is the kind of turnout that we see here. I've been participating in quantum industry days for a few years now. So this is a very impressive turnout this year. So it clearly shows that you're willing to invest time to learn about it, but I do see that it is becoming even more commercial, especially in Singapore, especially in Asia. If you pick any market, they are very, very serious about quantum. More and more announcements coming up. So you are at the right time, at the right point in your career where you can invest into this and double down. Investments are growing. If you pick the 25 numbers, if you especially follow stock market, quantum companies just yesterday in the 24 hours have gone up by 15-20%. It's not a financial advice, but I see that there's a lot of volatility, like the stock prices are going up and down, but a single day 15-20% change is very, very speculative, but it also shows that there is momentum in quantum. Strategic necessity. Quantum is no longer a choice. It is becoming important for sovereignty, tech sovereignty, for safety, for security, and countries are treating it that way. And when that happens, careers and ecosystems get built. And the last one is infrastructure. There are fantastic quantum companies. Again, some of them whom you will meet today, they're building amazing stuff. They are having scientific breakthroughs every month, every quarter. That shows that the hardware is becoming even more accessible. Infrastructure is progressing at a fast pace, which is perfect for any of you who is building a career here. With that, yeah, I'm open to questions, but I'll be happy also to collaborate, work together with you, or just have a chat on quantum and how you build quantum future, quantum careers, or quantum businesses. Thank you.
Thank you, Raghu.